respect to x, the rule is, you derive, the rule is for x. The rule is for x. But everything is multiplied, stays multiplied. So you write 6x times the log of y squared plus 3. When you derive with respect to y, now you change completely the point of view. So you derive y, it is inside the log, but the coefficient that is in front needs to stay the same. So you write the derivative of the log. And obviously you can multiply 6y squared y, whatever you want, but for me it's important the application of the rule. Okay? Does it work a little bit? The reasoning together, yeah. So, sorry, so the gradient you write for me, it is 6x the log, okay, nothing else than copying. You have to copy like that in a way that you like. There is not one way. And what about the second one? The second one, be very careful. When you derive with respect to x, you have a product. Because x is in the first term, x in the second term. So when you derive with respect to x, the first derivative is equal to, you derive the first one, and you don't derive the second one. Be very careful. The derivative of 2x is 2. You don't derive the second one. And then you have plus. You don't derive the first one. You just derive the second one. When you derive the second one, exactly the same rule. That's what you have. Because the argument goes down. In the numerator, you have the derivative with respect to x, so you have y squared. Obviously, you can simplify, I don't know in which way, in many ways. You can simplify x and x. Maybe here you have plus 2. Okay. And when you derive with respect to y, please try to wonder which is the difference. When you derive with respect to y, why don't you check here together? Do you believe that you have again a product? Because there is no y here, just there. So this is no more a product when you derive with respect to y. With respect to y, you have the first term you leave as it is, and then you have again 2xy. Obviously, you can simplify in the way that you like. And finally, the gradient, please write the gradient, will be 2 log xy squared plus 2. And the second one, it will be x and x. Maybe you have, I don't know, I check, 4x over y. Something like that. Please check my computation. Thank you. Okay. Another one. All together now. Fx, y, z is z with power x minus x, y, the exponential of xy. All together we develop the gradient of this function. Be very careful. When you derive with respect to x, what is going to happen? X is, please follow me very carefully, try to be so much concentrated on that. X is in the exponent. Okay? Again, x is in the exponent. Nothing else. X is in the exponent. I don't have any more rule than the exponential rule. It's like you have a number, because z now is a number, with an exponent that is x. So how can you derive this function? How can you derive the exponential function? You copy z with power x. Don't forget the log of the basis, because the basis is not e. You will derive an exponential function times the log of the basis. What about the second one? Be careful. Sorry, here you have a product. What does it mean? You have x and you have x again. So So which is the role of x and x? They are multiplied. You derive the first one, you don't derive the second one, plus you don't derive the first one, you derive the second one. So how can you derive that? You find minus and then you start. X, y. Can you tell me the derivative of x, y with respect to x? Y. Times, you don't derive the second one. Yes, no. Yes, no. Plus, because the minus is in front. Now, you don't derive the first one, so you just write x, y, okay? You copy it. You derive, be careful now, the exponential of x, y with respect to x. Exponential. Are we both able to derive the exponential? Sure, you copy it. Very well. Times the exponential times the derivative of xy, the exponent, the derivative of the exponent with respect to x. The derivative of xy with respect to x is equal to y again. So you write times y. And then you go on with the second one. Times y. What about the derivative with respect to y? Can you tell me something about this first term? The derivative is 0. Again, you have a very similar situation as before. So why don't you put the minus in front again? Which is the derivative of xy with respect to y? It is x times, you don't derive the second one. And then you have plus, don't derive the first one, and derive the second one. The derivative of x, y, with respect to y, it is equal to x. Very well. And finally, maybe the finest one is z with power x. Be careful. Which kind of function is z is your variable? X is like a number. Z is a variable, X is like you have Z with power 2, Z with power 3, Z with power 4. Which kind of function is this? It's a power function. Power because the variable is down. Are you able to derive Z squared, Z4? Why not? Put in front minus 1. So the derivative, please write in capital letters, it's very important. It is x times z with power x minus 1. Because you derive a power rule. Okay? It is no more an exponential function. Another one before that. Both of you, now all of you, all together, can you please derive y with power x minus 3xy squared. All of you please write these two derivatives. You are the instrument, you just develop them. Why don't you try to apply? With respect to x, y with power x, x is in the power, so it is an exponential. when you derive with respect to y with the power is a power rule. So the first one is an exponential rule. The second one is a power rule. It depends on the variable, where it is, yeah? So as we developed before, when you develop with respect to x, then you have, with respect to x, y power x log of y, because y is the basis. And very simple in the second part, minus 3y squared. And what you derive y as with respect to y, again you have x, y minus 1, minus 6xy. You derive with respect to y. Please be careful about these two things.
Why don't we write the power of y also?
Yes, it's x minus 1. No, it's not y. Why don't you? Okay, it's not y. Okay, it's x minus 1. It's not a y, but you missed. You can say that. There is a mistake there. Obviously. Thank you. Okay, as before, you have the power goes in front. The new power is the old one minus 1. Okay? Another one. F of x, y, z is 2z minus 1 minus 3x minus 1/2 plus 4y plus 100. Can you write the regions? With respect to x, with respect to y, and with respect to z. Put in front, minus 1. Because they are all power. Put in front, minus 1. When we derive with respect to x, this term is 0. 0. 0. You just derive this one. Put the power in front, minus, minus, you have plus 3 over 2. You agree with me? X, which is the new power?
Minus 3 over 2.
Minus 1, okay, minus 1, minus 1. So you have minus 3, check my computation over 2. Nothing else, because there are no products between variables. When you derive with respect to y, you have 4, very simple. When you derive with respect to z, put in front, minus 1. And then you have minus 2z, new power is minus 2. Okay? So you are able to write the gradient of a function. We generally work with 2 or 3 variables, no more than that. However, the theory is always the same. You can have 10 variables and you apply the same rules. Okay? And now, we need to extend the first order condition. You have any idea about that? So, one exercise is write the gradient. I give you a function and I ask you to write the gradient. Let's go a step forward. Do you have any idea of in which way I can extend the first order condition? The whole one was you need not just about the necessary condition. Let's say, remember the necessary condition, Fermat theorem. The necessary condition was take the first derivative equal to 0. So stationary points, remember like that, it's better. Stationary points in the whole theory, stationary points, were given by the first derivative equal to 0. Do you remember? Stationary points are when the first derivative is equal to 0. When you have one variable, it's like that. Now, which is the generalization that you can introduce? So, how you can deduce stationary points, in your opinion? The theorem, the Fermat theorem, how can be written in your opinion? Previously, you had one derivative, yeah? First derivative was just one. Now, the new criterion, the new rule is the gradient equal to 0. Okay. Now, you need to take the gradient and check when it is equal to 0, because you don't have anymore one derivative, you have 2 or 3. So the new condition for stationary points becomes when stationary points are given when the gradient of your function is equal to 0. So exactly the same. It's like a generalization because you had one derivative, now you have 2 or 3 derivatives. Let's take an example as soon as we can because you can fix. Imagine that this is your function, and I ask you check the stationary points for this function. Okay. What is about stationary points? Stationary points, okay, I need the first derivatives, I need the gradient to check when the gradient is equal to 0. Exactly the same as one variable. So now, the first derivative is, I believe, and maybe you believe, that it's not difficult in this case. Generally, when I ask you stationary points optimization, the function is not difficult at all. It's just for me to understand if the logical framework is clear. Okay, so imagine, if I ask you the gradient, maybe that the function is a little bit more complex because you just have to understand the rule you apply. But when I ask you stationary points, maxima and minima, the function is never difficult. Because for me it's important the logical framework. Okay? So now, just in this case, I believe that all of you are able to write the gradient. Okay? So the gradient of your function is 2x, 2y. There is no doubt, I'm sure about that. Now, stationary points, you discover stationary points where your gradient is equal to 0. But in this case, the gradient is given by 2 equations. So you have the first one and the second one. So a stationary point has 2 dimensions. So you need to find x and y because you work with 2 variable functions. And I'm sure that I really check this system, which is the value of x. Do you believe that we can do that? It's the first order equation, yeah? You divide by 2 in the both of them, and you discover that the stationary point is given by 0, 0. This is called stationary point. And it is given 1 point, just 1 point. And it is given when the gradient is equal to 0. Another example, if you have x squared plus xy squared. I ask you again for the stationary point. Okay. What you need is again check the derivative. If you check the derivative, you discover, I'm sure you know, 2x plus y squared. Why? Because when you derive with respect to x, you have 2x. When you derive with respect to x is 1, so you have y squared. Okay? Then you derive with respect to y. In this case, you have 2xy is equal to 0. So, which is the system that gives you the solution? In this case, you have exactly these 2 equations. No more 1 equation. You have 2 equations because you have x and y. What do you believe about that? I believe that there's not much difference between the previous case. Why? In this case, you may have x equal to 0 or y equal to 0, okay? Because they are multiplied, yeah? If you substitute in the first equation, x equal to 0 gives you y equal to 0. If y is equal to 0, you have x equal to 0. So finally, can you tell me which is the stationary point? Do you believe there is something different from 0, 0? What do you believe? If you take x equal to 0, then you have y equal to 0. If you take y equal to 0, then you have x equal to 0. So again, the same. So the stationary point is again 0, 0. It is called, be careful, stationary point. The point such that the first derivatives are equal to 0. The exam of the last year, 2 years ago, it was the following. F of xy is equal to x cubed plus xy plus 2y squared. Check the stationary points. So again, you need to discover which are the points such that the derivatives are equal to 0. How can we proceed? Please write the two derivatives of your function. Maybe you are able to do all alone in your best. With respect to x, x squared plus 1, nothing. With respect to y, it is x plus 4y equal to 0. Okay? Now, which kind of system we have here? X plus 4y is equal to 0. 3x squared plus y is equal to 0. Okay? How can you solve this system? Okay, you can have many ways. Okay, I follow the quickest one. So substitution is called. What does it mean? For example, I don't know what you like. In the first one, you can write something like that. You agree with me? I can write y is equal to minus 3x squared. You put on the other side. Then you can substitute in the second one. So you have x plus 4, you substitute, equal to 0. Okay? You just substitute instead of y. Okay, the first one, nothing to say in the first one. The second one, you have minus 12x squared equal to 0. So now the second one is a second order equation, nothing else. In order to solve it, you can write x, 1 minus 12x is equal to 0. So the stationary points are given by, you need to solve x. Okay. Here you have x equal to 0 and x equal to 1 over 12. Remember that y is this value. So when x is equal to 0, remember that you have two values for x. So you will have two values or more for y. So when x is equal to 0, you substitute, and you have any doubt about that? If you substitute 0, in this case you have again 0. So my first point is 0, 0. No doubt that this is a good point. Okay. Which is the other point if you have 1 over 11? Okay. Y is equal to minus 3. Then you need to substitute 1 over 11 squared. Okay. So it is 1 over 144. So y you can simplify if you like. So you can call P1 and P2. Okay. 1 over 11 and it was 4 to 8, 48. And this is the second column. Okay? So in this case you have 2 stationary points. It depends on the situation. But how can you classify stationary points? Now it comes, before the break, the idea is the following. Remember in one variable, you have 2 possibilities, okay? First order, second order. You could analyze the sign of the first order derivative or the value of the second order derivatives, okay? In the several variable field, in this field, you just have the second order condition. The first order condition is just for mathematicians, okay? In application, you have the second order condition. Now try to figure out what is going to happen. Be careful.